Imagine effortlessly multiplying your cherished plants, bypassing the need for seed catalogs and expensive nursery purchases. For centuries, gardeners replicated entire collections using a basic infusion made from wild willow, nature's own rooting stimulant, until this method mysteriously vanished, swiftly replaced by pricey commercial powders. Why did we abandon a technique that allowed a single tree to generate countless new plants? And who determined that nature's inherent advantage was not a commodity to be sold? The scientific revelations that follow will profoundly alter your perception of every garden and every bottle's promise. A willow branch breaks during a summer storm. It floats downstream, settles into the soft earth, and then something remarkable unfolds. Within mere days, delicate white roots emerge from the broken stem. No gardener, no greenhouse, no specialized powder, just water, a twig, and an inherent signal encoded deep within the plant. This is the natural wonder that willow trees exhibit on riverbanks and in ditches worldwide. The secret lies not in luck or enchantment, but in chemistry. Within the cells of young willow shoots, a hormone called indole-3-butyric acid, or IBA, courses through the tissue. 1BA acts as a messenger. When a branch is damaged or detached from its parent tree, 1BA surges to the cut site, instructing ordinary plant cells to convert into root cells. The command is unambiguous. Begin rooting, proliferate, survive. This is the very same biological directive that commercial rooting products aim to replicate. However, in willow, it is intrinsically present, circulating naturally through every new shoot and pliable stem. In the natural world, this chemical superiority means a single willow can dispatch legions of clones, each branch poised to take root wherever it lands. The process is so effective that even a slender pencil-thin twig, when inserted into moist soil, can develop into a new tree. Gardeners observed this centuries ago, long before anyone identified the hormone or packaged it for sale. While this phenomenon isn't exclusive to willows, few plants exhibit such reliable rooting behavior. The efficacy of IBA is not theoretical. It is visibly demonstrated, sprouting from every severed end. Here, nature's rooting cue is fully apparent, articulated in the language of cells and water, requiring no laboratory intervention. A willow cutting faces more than just the challenge of developing roots. Every wound is an open invitation for bacteria, fungi, and decay. Here, the willow's unique chemistry deploys a secondary defense mechanism within those vibrant green shoots. Salicin and related compounds transform into salicylic acid, the very molecule plants utilize to bolster their immune systems. When a stem is severed, salicylic acid signals the cells to prepare for an assault, activating genes that construct barriers against infection and stress. This is the same fundamental ingredient that inspired the creation of aspirin. However, in plants, its function is even more critical. The defensive message propagates rapidly, traversing the tissue like a wave. It directs cells to generate protective proteins, strengthen their cell walls, and impede the proliferation of pathogens. For a cutting, this translates to a greater likelihood of surviving the crucial initial days, when rot is most prone to strike. Laboratory investigations confirm that salicylic acid can diminish the risk of damping off and other fungal ailments in susceptible plant tissue. The effect is most pronounced in the youngest, most supple willow twigs, those richest in the active compounds that both stimulate rooting and protect against deterioration. This dual action, with IBA prompting root growth and salicylic acid guarding against decay, clarifies why willow water is more than just a rooting tea. It is a survival concoction concentrated in the newest shoots. The chemistry isn't solely about generating roots. It's about maintaining the cutting's viability long enough for those roots to form. In the 1960s, a discreetly circulated bulletin from the American Rose Society detailed an experiment that would become legendary among plant propagators. The test was straightforward. Rose cuttings, meticulously trimmed and prepared, were divided into groups. Some were soaked in plain water, while others were immersed in willow water, prepared by steeping young green willow twigs in boiling water for a day. The results astonished the gardeners. The willow-treated cuttings rooted more swiftly, produced a greater abundance of roots, and survived at rates exceeding any prior method they had attempted, including the commercial rooting powders available at the time. The bulletin asserted that willow water exhibited a rooting effect unparalleled by any previously known substance, including plant hormones. The news spread through gardening clubs and extension offices. For softwood cuttings, those delicate, pliable stems collected in spring and early summer, the benefit was particularly evident. Even species considered notoriously difficult to root, such as old garden roses and certain shrubs, responded favorably. Experienced cultivators began to discern a pattern. Willow water didn't merely assist easy-to-root plants, it significantly improved the chances for challenging ones as well. In optimal scenarios, rooting rates soared from 50% or 60% to over 90%. The experiment didn't just prove a point, it provided gardeners with compelling evidence to trust an ancient technique over a modern product. For every skeptic, there were piles of successfully rooted roses demonstrating the efficacy of willow water when conditions were optimal. Skeptics have long questioned whether willow water genuinely lives up to its reputation, especially when compared to commercially available rooting powders. Not every cutting responds identically. In controlled trials, easily rooted species like apple often display minimal difference. One study found that 96% of apple cuttings rooted in willow water, while 92% rooted equally well in plain water. For plants that root without much encouragement, willow's effect can be subtle, almost negligible. The narrative shifts with more challenging species. In commercial nursery experiments involving petunia cuttings, low concentrations of willow water enhanced survival rates compared to untreated controls, yet still fell short of synthetic indole-3 acetic acid. At higher concentrations, willow extract actually became toxic, eliminating every cutting in the group. In olive trials, only bark-derived willow water made a difference, and then only when combined with commercial hormone. The results are clear. Willow water is not a universal panacea. Its advantage appears strongest with softwood or semi-hardwood cuttings, young, pliable stems already predisposed to rooting. Hardwood cuttings or those from resilient species rarely benefit. Standardization presents another obstacle. The potency of willow water varies depending on the species, age, and season of the twigs, as well as the steeping time and temperature. No two batches are ever exactly alike. Commercial powders deliver a precise dose every time. Willow water is always somewhat of a gamble. Therefore, the best way to determine its efficacy is to test it yourself. Conduct a simple experiment. Take matched cuttings from the same plant. Treat half with fresh willow water and the other half with commercial powder or plain water. Monitor the rooting percentage, root growth, and any signs of rot. Let the data speak for itself. Nature's formula might surprise you, but only if you put it to the test. In 1935, within the confines of the Boyce-Thompson Institute in Yonkers, New York, two researchers, Percy Zimmerman and Alfred Hitchcock, embarked on a mission to unravel the mysteries of plant growth. Their investigations transcended mere tradition or folklore. They systematically tested pure compounds, one after another, seeking the specific molecule capable of transforming a stubborn cutting into a rooted plant. The breakthrough came with indole-3 butyric acid, IBA. Unlike the natural auxins found in willow water, IBA proved both stable and consistently potent, stimulating root growth across a broad spectrum of species. Their findings earned them the prestigious Newcomb-Cleveland Prize from the American Association for the Advancement of Science that same year, a rare honor for plant science. The 1935 paper did not merely adorn library shelves, It ignited a revolution in horticulture, shifting propagation from rudimentary kitchen experiments to a discipline rooted in chemistry. The discovery of IBA's power was not just a scientific triumph. It marked a pivotal moment when the established rules of plant cloning were rewritten. Suddenly, nature's confidential recipe faced a new, synthetic competitor. Within 3 years of the Boyce-Thompson Institute's groundbreaking discovery, the science of rooting transitioned from the laboratory to the commercial market. Patent applications commenced in 1937, with Merck and Company securing exclusive rights to synthesize indole 3-butyric acid on an industrial scale. The chemical process detailed in United States Patent number 2,248,155 promised high yields and low manufacturing costs, a formula primed for mass production. By 1941, Merck launched Hormone, a powdered product that delivered a consistent dose of IBA to every gardener's hand. The product's appeal was straightforward. It was shelf-stable, scientifically validated, and ready to root cuttings on demand. Hormone arrived in small tins and plastic vials, priced for the home gardener, but scaled for national distribution. Advertisements in trade journals and garden catalogs promised miraculous outcomes. No more steeping willow twigs, no more waiting for the opportune season. For the first time, a plant's intrinsic rooting signal was packaged, branded, and sold as intellectual property. The knowledge that once flowed freely from a tree now traversed through patent offices and into retail stores, transforming a naturally occurring biological process into a lucrative product line. A small tin of Hormone powder retailed for less than $1 on hardware store shelves in the 1940s. Adjusted for inflation, that amounts to approximately $10 to $20 today, roughly the cost of a contemporary rooting powder jar at any large garden center. The proposition was irresistible. A product that guaranteed consistent results, eliminated guesswork, and boasted a shelf life measured in years, not days. Gardeners who once gathered willow twigs from riverbanks now reached for a branded powder, confident that every scoop delivered the identical dose of IBA season after season. Retailers readily embraced this model. A single willow tree could supply an entire neighborhood for free, but a jar of powder sold repeatedly, year after year. The economic incentives favored continuous sales over natural abundance. Advertisements in gardening publications once highlighted Hormone and Roan as advancements in science, consistently available, predictable, and pre-packaged. The financial disparity widened, not merely in monetary terms, but in a decline of self-sufficiency. The adoption of chemical methods wasn't about superior outcomes. It was about transforming a local, renewable resource into a nationally marketable item. The highest concentration of a plant's rooting signals is found in young willow twigs, those pliable shoots, often bright green or golden yellow, no thicker than a pencil, that bend without snapping. Older branches contain more bark and fewer active compounds crucial for root formation. Therefore, prioritize fresh growth from spring or early summer. Gather a handful of these flexible twigs. Remove any leaves and cut them into 1-inch sections. A greater exposed surface area will facilitate a more efficient leaching of hormones and salicylic compounds into the water. There are 2 methods to extract the inherent chemistry. The rapid approach involves boiling water. Place the chopped twigs into a clean jar or bucket, filling it about 1/3. Pour just enough boiling water over the pieces to fully submerge them. Seal the container and allow it to steep for 24 to 48 hours. The heat quickly extracts auxins and salicylic derivatives, forming a pale, weak tea. Once the water cools to room temperature, strain out the solids. The resulting liquid is ready for immediate use. The slower method is even simpler. Cover the twig sections with cold water instead. Let the mixture sit at room temperature for 2 or 3 days, permitting the compounds to gently diffuse. Although this process takes longer, it can be equally effective. Once the water acquires a faint amber tint, strain and save the liquid. Both techniques produce a fresh infusion with the identical active ingredients that Willow employs for rooting itself along riverbanks. The next phase involves application. Utilize this natural solution to propagate plants without visiting a garden center. With fresh willow water prepared, the subsequent step is deceptively straightforward. To give your cuttings the best possible start, begin with a pre-soak. Submerge the trimmed ends of your softwood or semi-hardwood cuttings in the willow solution, just the bottom 1 or 2 inches. Allow them to sit for several hours, or even overnight if you are working with plants known for slow rooting. This soaking period enables the natural auxins and salicylic compounds to permeate the tissue, preparing the cells at the cut site to transition from healing to rooting. After the soak, transfer your cuttings to their chosen rooting medium. Perlite, sand, or a light potting mix all work effectively. Water them using the leftover willow solution, ensuring the soil is thoroughly damp. For the initial week, substitute willow water for regular irrigation. Each watering delivers a fresh dose of rooting signal and immune support, enhancing your chances of success during the vulnerable period before roots emerge. Some gardeners root cuttings directly in jars of willow water, but this method can restrict oxygen and occasionally lead to rot, particularly if the water isn't changed frequently. For most species, the soak and plant method achieves the proper balance: enough hormone to initiate root growth and sufficient airflow to maintain their health. If you have surplus willow water, refrigerate it and use it within 2 weeks. Beyond that, the active compounds begin to degrade and the rooting efficacy diminishes. With this technique, you are not merely imitating willow's natural behavior, you are harnessing the same chemistry at your own potting bench. Willow water is a dynamic solution, not a commercially bottled product. Its potency stems from fresh plant chemistry, but this freshness comes with a limitation. Once strained and stored, willow water begins to change. Microbes, bacteria, and yeasts that hitchhike on every twig find ample nourishment in the residual sugars and plant compounds. Within a week, at room temperature, the water may become cloudy or develop a sour odor. By day 14, most batches have lost their effectiveness. Auxins and salicylic acids start degrading, while microbial growth accelerates. The rooting boost fades, and what remains is barely better than plain tap water. Refrigeration slows this process, extending its useful life to about a month. However, it cannot stop it entirely. The active hormones are not shelf-stable. They weaken with each passing day. This is why willow water never became a retail staple. Unlike the white powder found in garden centers, you cannot store a jar of it on a shelf for years. Nature's formula is potent, but ephemeral. If you produce more than you need, there is one method to preserve its strength. Freeze it. Pour the excess willow water into ice cube trays, seal them, and place them in the freezer. The cold arrests both microbial growth and chemical breakdown, locking in the active compounds until they are required. The solution remains nearly as effective as the day it was made. For gardeners seeking abundance, this is the closest you will come to bottling the untamed energy of a willow branch. Fresh, ready, and always accessible, provided you respect its limitations. Today, plant propagation is still primarily influenced by what can be packaged, not by what performs optimally. As patents expire and knowledge disseminates, more gardeners are reclaiming nature's unbottled code. The willow's secret was never lost. It was merely rendered inconvenient. In a world driven by shelf life, true abundance continues to grow wild, awaiting those willing to create it anew. In the realm of agriculture, a crucial decision surfaces. What crop will you choose to cultivate? This pivotal choice dictates not only the immediate yield, but also the prosperity of the land and the well-being of those who tend it. Considerations extend beyond mere profit, encompassing ecological impact, nutritional value, and market demand. Consider the diverse array of options available. Grains that sustain populations, vibrant fruits packed with essential vitamins, robust vegetables offering a staple for countless meals, or specialty crops that cater to niche markets. Each presents its own set of advantages and challenges, demanding tailored approaches to planting, nurturing, and harvesting. The selection process often involves an intricate dance between tradition and innovation. Farmers may lean on generations of ancestral knowledge, cultivating crops that have historically thrived in their specific climate and soil composition. Simultaneously, they might explore novel varieties, developed through modern agricultural science, offering enhanced resilience to pests, improved yields, or superior nutritional profiles. This balance ensures both sustainability and progress within the agricultural landscape. Ultimately, the choice of what to cultivate reflects a confluence of practical needs, environmental considerations, and personal aspirations. It is a decision that resonates through seasons, influencing economic stability, food security, and the enduring vitality of the earth itself. The endeavor is a testament to human ingenuity and our deep connection to the land that provides our sustenance.